Hello and welcome to Chandara Academy. Today we will solve the first exercise of the 2021 exam. It's about the limits. We will see all the techniques that you need to compute these limits, and we will try to understand what's going on. So the first limit, we're gonna name, let f be the function under the limit. So that given x gives square root of 3x squared minus 11. So that said, we're going to try to compute a equal the limit when x tends to 3 of f of x. Okay, what is the question that we want to ask immediately? Is f defined on any interval including 3? Why? Because if f is defined on any interval around 3 and is continuous, if we are in this kind of condition, limit of f of x when x tends to 3 would be f of 3. So are we in this case? Okay, so is f continuous around x is equal to x is equal to 3. Where could be the problem? Let's write again. For x, f of x is equal to square root of 3x squared minus 11. When have we got a problem? Okay, so around 3 we've got 3x squared minus 11. That is more or less equal to 27 minus 11 is equal to 16. Okay, and having so when do we have a problem? Okay, the function square root gives us some issues when what's under is negative strictly. Okay, so when would it be? So let's solve 3x squared minus 11 negative strictly equivalent to x squared under 11 third equivalent to x under square root of 11 third, and that's strictly less than 3 and even 2.5. So we have got what we were looking for. So an interval around 3, so an interval where f is continuous. F continuous because the argument the argument 3x squared minus 11 is not strictly negative. So, how do we justify the limit now? So, f is continuous around 3. So, limit, so a is equal to the limit when x tends to 3 of f of x is equal to the limit when x tends to 3 of square root of x squared, squared minus 11 is equal of 3 times 3 squared minus 11 is equal to square root of 16 is equal to 4. So a is equal to 4. We answered the question. Okay? So that's the first and most simple limit you will have to compute. So these kind of limits are really easy to do. Let's solve the other one. So let's call b, this is the sign to say we call or we define something. So let's call b the limit when x tends to pi over 3 of j of x, with j of x equal to square root of 3 times sinus of x minus pi over 3 over pi over 3 minus x. So here, just look at the value we want to tend to. So pi over 3. Have we got a problem with j of x? Of course we have a problem, because when x tends to pi over 3, this tends to 0. So we have a problem, because on the other side, this tends to sinus of 0 is equal to 0. So we have something like 0 over 0. This is undefined, but we can still solve this. This is a little bit more difficult than the other one, but we can do it just by seeing j of x is equal, just by seeing that what's under the sinus and what's here are quite the same thing, one being the inverse of the other one. Okay? So what we want to do first is have the same thing into the sinus or into there. Okay? So let's do a little bit of calculation. Let's add a minus the top and a minus at the bottom. Okay? So minus times minus is equal to nothing. Is equal to a plus. So we didn't change anything, but adding a minus on the top and a minus on the bottom. Okay? Because we want to have the same thing into the sinus and into the bottom. So pi over 3 minus x. And now let's distribute the minus of the bottom to all the bottom is equal to minus square root of over 3 and x minus pi over 3. We now have the same thing here and here. And why do I want it to do that? Because we know the limit when when x tends to 0 of something which has the form of sine of x over x. Okay, we know this limit, so we want our limit to look like that. So now let's just change variables and call x is equal to x minus pi over 3, and the limit in x is equal to pi over 3 will change and be, so lim when x tends to pi over 3 will become the limit when capital X tends to 0, because little x is equal to pi over 3 implies capital X is equal to 0. As simple as that. So our limit b is equal to the limit when capital X tends to 0, we change the variables, of minus square root of 3 times sinus of capital X over x. This is simply a coefficient. Okay, so easy. But this, we know it, will tend to 1. So this is something you should know. I can explain it very quickly. So limit of sine of x over x when x tends to 0 is equal to limit of when x tends to 0 of sine of x minus sine of 0 over x minus 0, and this is the definition of the derivative of sinus. So sinus prime times x, sinus prime of x when x is equal to 0 is equal to cosinus of 0 is equal to 1. So that's the proof. Okay, we don't need it. You need to know this kind of form. So b, to answer our question, b is equal to minus square root of 3 times 1 is equal to minus square root of 3. And we are done with the limit. Okay, so now limit number 3. So let's call C as usual. C equal the limit. Just let me have a look. Limit of 2x minus 7 minus 11 log, so ln of x when x tends to plus the infinite. These are the compared, we will use the compared, so compared growth. Okay, what does it mean? What does it mean? It means that we know when there are some additions, okay, that when we go to the infinite, something is going to be stronger than another, okay? So, for instance, exponential of x is greater for large x, so it includes going to the infinite. Exponential of x is greater than any power of x for all a strictly superior to 1, okay, and this is strictly superior to, this is larger, of ln of x. Okay, so you need to know, so to know perfectly this kind of things, because we will solve this problem really easily. So you can see that we've got something polynomial here, one constant here, and something with ln of x. So I just said that what's going to win in the infinite is going to be this term with x, because its influence, okay, its influence will be greater than the ln of x1. So this infinite, so this will tend to plus infinite, will be larger, greater than this minus infinite. Okay, so if you want to justify it, you just say that c is equal to the limit of h of x when x tends to plus infinite, h of x being this big thing, okay, h of x, so is equal to the limit when x tends to plus infinite of x, okay, so I factorize the whole thing, x times 2 minus 7 over x, plus 7 over x minus 11 log of x over x. Okay, so when x tends to plus infinite, we will have 2 that tends to 2, okay, when we get 2 that tends to 2, 7 over x that will tend to 0, easy, and minus 11 log of x over x will tend to 0 because of the compared growth. Okay, so we will have there 2 plus 0 in the infinite, and this thing will tend to plus the infinite. So easily we will have c is equal to plus the infinite. So this product, okay, this one, c is equal to plus the infinite. So to do a little resume, we used for a the proper continuous function properties, okay, so when f continues in a, limit when x tends to a of f of x is equal to f of a. So that's the first one. For b, we changed variables, and for c, we used compared growth. Okay, so perfect. This will conclude our video. I hope you enjoyed it, and I'll see you the next time. Bye.